10-4 is dealing with perimeter and area of similar figures. So we've been talking about figures that are similar, not congruent anymore, right? They're similar, they're proportional side lengths. So here's how it works. We've been talking about scale factors, right? The scale factor of, remember when we did the dilation? The scale factor was 1 to 2 or 3 to 5, or, there was that scale factor. So I'm going to show you how the scale factor converts into two different types of ratios. So this first one, we're going to say this. If the scale factor, if the scale factor of two figures is A over B, then, what happens is you come up with a perimeter ratio and an area ratio. So then the perimeter ratio is A to B. Okay, so the scale factor and the perimeter ratio are always the same thing. Here's a little example for you of how this works. You don't necessarily need to draw this. I just want you to understand what's going on here. Let's say we have these two triangles and they are similar triangles. So this is 3, 4, 5, and this is 6, 8, 10. Okay, think of it this way. If I asked you what is the scale factor of these two triangles, could you tell me what that is? Do you remember how to do that? The scale factor? Something over something. So like you pick corresponding sides. So 3 over 6, right? So 3 over 6 or 1 to 2, okay, if you reduce it. Or you could have picked two different sides, 4 over 8, right? 4 over 8 is 1 to 2. So this is a scale factor, 3 to 6, 1 to 2, okay? Well, what they're saying is the perimeter ratio. So the perimeter is what? What is a perimeter? The outside, the distance around a figure, right? So if we found the perimeter of these two figures, we'd go 3 plus 4 plus 5. So that would be 12. Okay, then if we found the perimeter of this bottom one, 6 plus 8 plus 10 is 24. Well, if we turn that into a ratio, 12 over 24 is 1 to 2. So my perimeter comparison is 1 to 2, and my scale factor comparison is 1 to 2. So basically what they're saying is don't find the perimeter, right? Don't take the time to add up all your numbers. Just take two sides and compare them, which is your scale factor. Your scale factor will always be your perimeter ratio. So if the scale factor is A over B, the perimeter ratio is A over B. Okay? So don't worry about adding up a bunch of numbers, and I'll show you in a minute what I mean by that. But this is why they say it'll work out. Okay, so the perimeter ratio will be A to B. The second thing is the area ratio will be A squared to B squared. Okay, so now you would take that original scale factor of A to B and you just square both of them, and that will be your area ratio. Okay, so let me show you real quick what I mean by that. Let's say you have, bless you, a scale factor for two figures, that is 3 to 4. Okay, if I asked you what is the perimeter ratio, what would that be? What was the relationship? Scale factor was A to B, perimeter ratio was A to B. So if the scale factor is 3 to 4, what's the perimeter ratio? 3 to 4, right? So your perimeter ratio is always the same as your scale factor. okay? Then if they say, okay, well then what's the area ratio? What do? 9/16. You square them, right? So the area ratio is 3 squared over 4 squared, which is 9/16. Okay, does that make sense? Yes? Somewhat? So scale factor and perimeter ratio will be the same. Area ratio, you're just going to square them. Okay? Okay, so we're going to do a couple examples just to see if we're getting there. First example, it says these two figures are similar. Find the perimeter ratio these R's don't want to write right now, and the area ratio. All right, so we're going to have two trapezoids. Okay, and it says they're similar. So this is 6 meters. This is a length of 9 meters. And I want to know the ratio of their perimeters and the ratio of their areas. Now what you have to make sure of is that you always reduce first. Okay, so we're going to start with the scale factor. Okay, what would your scale factor be right now? What over what? 6/9, right? You're just comparing the two lengths. What does that reduce to? 2/3. Okay, so your scale factor right now is 2/3. I want to know the perimeter ratio, which is 2/3. And I want to know the area ratio, which would be what? Not 4/6, 4 over, you're squaring both of them, right? So 2 squared over 3 squared is 4/9. So your perimeter ratio is 2/3, your area ratio is 4/9. Does that make sense? Okay. Okay, so then we're going to take it kind of to the next level here. I wish that was it for you, but you got a little bit more. For this one, they're going to say the area of the larger figure, and I will draw your figures in just a minute, is 96 square inches. Find the area of the smaller. Okay, so I'm going to give you two parallelograms. This first one is 6 inches, and the second one is 8 inches. Okay, so now normally to find the area of a parallelogram, we would do base times height, but we don't have a height, okay? But because they told us the area, bless you, of the bigger one, we don't need the height because now we can just use these ratios. So this is pretty much giving you a shortcut to finding area is what they're doing in this problem. So we need an area ratio if we're going to find the area of the smaller one. How can I find an area ratio right now?
Area of the bigger one?
No, last one we were just finding the ratio. Now we're going to find the actual area of the figure. So we're going to do what we did in the last problem and take it one step further. So what is my area ratio going to be? What's my scale factor? Scale factor is 6/8, and we have to reduce. So what does that reduce to? 3/4. Okay, so my scale factor is 3 to 4. We want an area ratio. because we're dealing with area. So what would my area ratio be? 9 to 16, right? You're going to square both of those. Okay, so, because it's area, right? So you square it. So now here's the deal. That's where we stopped in the last problem, was we found the area ratio. Well, now we want to know what is actually the area of that smaller figure. The area of the bigger one is 96 square inches. We want the area of the smaller one. So what we can do is we can use that ratio. If the comparison of the two is 9 to 16, we can say 9 over 16 equals something over something. We're going to use that 96 as one of our somethings, one of our numbers. Think for me where that should go, on top or on bottom? On the bottom, because it's associated with the bigger figure, and the 16 is associated with the bigger figure. So we're going to put a 96 here, an x here, and then we're going to cross multiply that. Okay, so we get 16x equals 9 times 96 is 864. And then we're going to divide by 16. So it comes out to x equals 54. And that's an area. So the area of this smaller figure is 54 square inches. Okay, so you just took your ratio, your area ratio, and you set it equal to the areas of the figures. Well, this one we don't know, so we call it x. This one was 96, so that's going to go on bottom because it's across from the bigger of the two. And then you cross multiply. With me on that? Okay. Okay, this last one. Yeah, we're going to do one more. This last one kind of works backwards. So third example here. It says the areas of two similar triangles are 50 square centimeters and 98 square centimeters. Okay, I want to know what is the area ratio and what's the perimeter ratio. Okay, so think about it this way. If we look back at the last question, our ratio of the volumes was 54 to 96, right? It was 54 for the one, 96 for the other. Well, that's essentially what they gave us here. They just didn't give it to us as a ratio. So all you have to do to start is take the two areas and make them a ratio, because those are our areas making our area ratio. So you're going to take the 50 and the 98 and just put them over top of each other. Okay, so technically this is our area ratio, but what do you suppose we have to do with those numbers? I said it at the very beginning, you always have to reduce, right? Okay, so if I divide both of these by 2, what does it reduce to? $50 divided by 2 is what? $25, right? So you'd have 25. Do you know what 98 divided by 2 is? 49. Okay, and that's as low as we can reduce it. So that's the first part of the problem, is they wanted us to find an area ratio. That's it. Okay, but think about what an area ratio is. An area ratio is your a squared over b squared. So right now, a squared over b squared is 25 over 49. So what can I do to that to make it A over B? Right, you got to square root them, because if it's been squared, now we have to square root. So this would be the square root of 25 and the square root of 49, which is 5 over 7, which is your perimeter ratio. Okay, so yeah, you're just working backwards on this one. They give you the areas, you reduce them, and then you square root them. Does that make sense? Okay, so let's say, I'm just gonna do one more, that same type of problem. Let's say you had an area of 16 and 36. Ooh, no, I don't want that. 16 and 81, okay? What's your area ratio right now? 16 over 81 would be your area ratio. And you can't reduce 16 over 81, so you would just leave it as that. So what is your perimeter ratio? 4 over something. What's square root of 81?
Oh,
9. 9, right.
Is this the same problem?
It's the exact same type of problem. I just gave you 2 new numbers just to see another setup of it. So technically, this would be considered a new problem, but it's the exact same type of problem. I just want you to see it again. Okay, so put them over top of each other to get your area ratio. If you can reduce it, reduce it. This one you couldn't. Excuse me.
Oh, yeah,
Square root. Yeah, square root it to get the 4 over 9. Okay? Questions on that?